This is the second talk I'm doing today. I had one that was right before the lunch break, so I was the guy who was between you and your lunch. Now I'm the guy who is between you and your drinks, because afterwards just a party. I guess there's the closing keynote, then the party, but still, after me, drinks. So I'm going to tell you something about speed index. Has anybody in here heard of speed index already? Yeah, cool. 2 guys? Could be more. That's why you're here. I want to tell you a story. I had a client once, which I created a website for. And this client was very, very picky about his briefing document. It was about 300 pages, detailing every little bit of the website, how it should work, how it should look, how it should function, how it should behave. And I can't remember the whole document anymore. I never even read it fully, to be honest. But there was one line in this document that haunts me to this very day. And it was, the page has to load in less than 3 seconds, or in 3 seconds or less. So we were, all right, let's do a page that loads in 3 seconds or less. We brought our deliverable to the client. He opened it up. And he said, oh, that's too slow. We said, no, it wasn't. And he said, yeah, that's way too slow. I mean, no, it wasn't. Yeah, yes, it is. No, it isn't. So that was us arguing all the time, and that's how it actually went on for about a week or so. And then we made the worst mistake possible. We said, yeah, well, it's faster than our machine. So the error has to be with yourself. Don't do that. Don't say it works on my machine. You won't get a badge for it, even if you can order a T-shirt on Redbubble or something like that. That Dothraki say, have no word for works on my machine. So don't do that. Other than that, use metrics. Try to define some good metrics you can measure, and try to compare it from different installations, from different users. The things we wanted to measure with this particular project were 2 events. One was DOM content loaded. That's the well-known document ready. And anybody who has written some line of jQuery knows this. And the other one is window unload. Document ready tells you that the document is ready for interaction, so the user can interact with the document. And window unload tells you that every source has been loaded. Not only the document, but also the sub-resources like images, style sheets, JavaScript files. And with a little JavaScript object that is in every browser to this date, with window performance timing, we were able to measure those timings when each event has happened. So we had some timestamp. The event happened at that particular time. And we knew how long it took from the response or from the request to the window unload event. That's the full range over there. You can find timings in there. So that was for this particular project a very good deal, because we could say, okay, window unload fires after 3 seconds for a particular amount of browsers on your machines, on our machines, on the client's machines, on your client's machines. However, window unload, why it tells you, okay, everything is there, everything has loaded, like it said on the specification, it has to load in less than 3 seconds. It's not always that true. I'll show you a screenshot how Gmail looks like when window unload has already been fired for 2 seconds. Window unload actually loads the JavaScript application that loads Gmail. So it can be tricky. That's why some clever folks at Google found a metric that is more to the likes of the user. A metric that tells you how your website actually behaves and how it looks like and how finished it is. Say hi. No worries. And the metric is called speed index. So what is speed index? Well, speed index mathematically is that. And if you're not good in math, I don't know, it doesn't matter. What's important is this parameter, the only parameter that this function has, visually complete. So what speed index measures is how visually complete is your site. How near the end state will it be? So what does it mean? Let me show you. This is a film strip of a website that is about to load. So first step in calculating speed index is create the video frame by frame for each millisecond of your website and how it looks at that particular time. So that's what we are doing. The site is loading, and at some certain time, it has finished. So step 1. Step 2, build a DeLorean, jump into that DeLorean, and go back in time and compare the last frame to each frame that you have measured up till now. And for each frame, for each comparison, you get a number. Either 0, which means it's totally the same, or 1, which means it's totally different, or something in between. Sum it up, and you have the speed index. In this case, oh, that was a random number. I can't believe that it's 3, 4, 5, all the randomness. You can measure speed index with this little page, web page test. Anybody knows web page test? Yeah? I use it on a daily basis. You can just put in URL, wait a few seconds or minutes, and you get all the things. You get a video of the visual progress, you get the speed index, you get the film strip, you get waterfall charts, you get optimization stuff. So a really cool website. And the cool thing is also you can compare your site to other sites or to sites or to your previous version of sites. So let's compare two of those calculated speed indexes. This is a chart. It tells the time in seconds the page takes to load and the grade of visually completeness. We have one site that is rather complete right at the beginning. After 1 second, it's about 95% complete. And then let's say it just waits for the web font to load, and that takes about 7 seconds. And here, the window on load event triggers, there it's finished. But yeah, the speed index says at this point, it's pretty much finished. And then you have another site. It's the other way around. After 1 second, you just get a little bit, maybe the header. Then you wait some quite long time, let's say for a background image or something like that. And then the image is loaded. You get up to 90% immediately in a high jump. And then you just have to wait for some web font again. Both websites take the same time, 8 seconds. But one feels more visually complete than the other. And the speed index is now, for this site, the area right above here. And for the other side, the area above here. And you can visually see that the other side has a much higher speed index. Speed index is given in milliseconds. So it's the average time your website is visually complete, calculated in this way. And as I said, you don't have to do it on your own. You can use web page test for that. So I'm talking about difference between frames. So how is the difference calculated? Is it something that we can rely on? Is it robust enough that we can say, okay, how you're calculating this difference and what it implies for us is something that we can build upon. So usually I thought difference is just, subtracting images. You can do that in image processing, like this image minus that image is the difference, and then you have some sort of number. I was kind of mistaken. I'll show you why. This is the Ruxit web page with the web font. This is the Ruxit web page without the web font. So if I would calculate it this way, between the no web font version and the web font version, we have 6% difference, says our image processing tool. Now I have one version that doesn't feature a font at all. That's a behavior some browsers have. Safari, for instance. Who has experienced that you wait quite some time for a font to show up? Yeah, there's one hand. A few others, yeah, not sure, don't like that, yeah. So here we don't have any web font at all. Here we have some, and it has less difference than it had before. So you just can subtract stuff. Just to be sure. This is not good for the user because you can't read text. This is good for the user. Even though the web font is not loaded, he actually can read stuff. So our goal would be that the user gets the most important information as fast as possible. And if you look at the difference images of those two, you actually see that there is much, much more noise, even if it's just changing web fonts. Here it's not that much noise because, yeah, there wasn't something to begin with, so it just drew upon it. So when I found that out, I thought, okay, the speed index might not be that robust, but then I read the specification a little better, And they said, okay, they came upon the same problem, and they decided to use histograms instead. Histogram, they're just analyzing each and every pixel and putting the R, G, and B values of the pixel into some chart, which is okay. If you have RGB or R value of 255, it's on the right side. If it's 0, you have it on the left side. And then they sum up the amount of pixels for each one of those values. And you get such a chart here. And you can see from the chart that the distribution of the blue from the web font version and from the not web font version is roughly the same. So that compares really good. From the I don't have any font at all version, it's a totally different distribution. So with a difference calculated in that way, you have a very robust metric telling you the actual feel of the user. The user wants to read text, and he can get text. And it's more alike than the other text version, and nothing at all alike as this text version. Same for JPEG. This is a baseline JPEG. You know, baseline JPEGs are loaded square by square or line by line. That's why it's called baseline JPEG. And that's an image that's 10% complete. Do you have any idea what's inside this image? Any idea what's going on there? Nobody? Maybe after 50%? Okay, some of you. And with 100%, I gotcha. Sorry. So for the user, it's really important that he knows what's coming with that image. He could get rickrolled otherwise. In speed index, that means if that image would be loaded gradually over 1 second, it would have a speed index of 100, sorry. Now go to progressive JPEG. Progressive JPEG gives you a low-res version and then adds the details gradually. So you already see that this is a puppy, even after 10%. After 50%, you kind of see that the puppy is not angry, but rather smiling. And here's the total cuteness. And doing this way, the speed index gets much, much lower. Like the image is already 77% complete at the beginning, if you do a histogram comparison. So that means if it loads gradually over 1 second, you just have a speed index of 113, according to those tests. So again, speed index has a very low score for the build-up of this image, which is good for us as users, because we already see what's inside there. So I want to show you, based on this information, a few tricks how you can boost up your speed index or lower the score, because a low score is good. I was talking about web fonts a lot. And we are handling web fonts now in this way because we think it's not only good for the speed index, but also good for the user to see. We are checking if you're dealing with a modern browser. If you're not dealing with a modern browser, he doesn't get any web font at all. He just gets the fallback font. It's just another resource he has to load, and he won't be happy with it, we think. So no web font for legacy browsers, for old IE. We are just serving WOF, Web Open Font Format, or WOF2. And then we're going to check if we have the font already loaded the previous time. We look up in the local storage of our browser if there are the font files. And if the font files aren't there, we're going to load them. If they are there, we're going to show it. So that's the diagram. Those conditions have to be met for us to show the web font. Otherwise, the user does not get any web font, and he still sees text. That's in the pre-render step. In the post-render step, we are checking if the local storage is actually available, so we can download the font and put it in there. If not, he doesn't get any font. Then we are going to download the font asynchronously. The website's already there. The user's already reading something. Then we load the web font. Then we save it in the local storage, and then we're going to show it to the user. Or we wait for the next time. If we would say, leave the font in the local storage and just show it the next time, then it would kind of behave like a property that's now coming to the CSS standard, which is font appearance optional, or something like that. Font something optional. So actually something that is considered best practice and finds its way into the CSS specification. The thing is, with all the no font stuff, or people not getting fonts, we just have a very small user base who actually don't get any font. The other ones are getting it optimized because downloaded, saved, and saved up for the next visit. In the next visit, he already has it. Another technique that we are using is critical path CSS. Anybody here heard of critical path CSS? or critical CSS, you again. This is a very rudimentary timeline chart made by yours truly. That is the document, the index.html document that is loaded. And now, usually, when the index.html is at its end, it's going to be parsed. And when it's parsed, it finds kind of a resource, like that's the main CSS file that I'm going to reference in my head. So what the browser does is now, okay, in the head there's a reference to a CSS file. I'm going to stop rendering right now because the CSS file might have information that's important to me for rendering. So rendering is blocked, and he waits until the resource has finished loading and continues. Then he sees, oh no, there's another resource, like a JavaScript file. JavaScript can alter the DOM. JavaScript can change the document. So I'm going to wait for it, stop rendering, that also blocks rendering, and waits until the resource is loaded. And then he's going to start render. After every blocking resource that has been loaded, rendering happens. So what if we could say that we want to start render directly when the first document arrives? And this is where critical CSS comes in. So you again have the document, but instead of having blocking resources in the head, you have a style attribute. And the style attribute contains every CSS rule necessary for you to render the above the fold content, just the content of the very first viewport. So with the resource, with the document directly, you get all the necessary information to display the very first frame of your document. And then, asynchronously, you're going to load the CSS file and the JavaScript file. Load CSS is some software from the Filament group. You find it on GitHub, and it does it just perfectly. There's lots of other information too on this website where you can find tools for creating this critical CSS so that you don't have to do it by yourself. The user gets the first screen directly after the document is loaded and already has something to view. So considering these two optimizations, I want to show you what it did to the Ruxit website when we integrated them. This is the old website. I colored it red so that you know that change is happening. And I'm going to press this camera button that's from the Chrome DevTools, and he's going to reload the site and creates a film strip of the site building up. So I'm going to click here. And as you can see, it's recording, it's loading, nothing is changing. Now I get a few information already, waiting for the other stuff. It's constantly loading, 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 and waiting. And it takes about 8 seconds. Then you have something like the web font was already there, and you have the whole start screen, and he's finished. And as you can see, after about 8 seconds, the DOM content was loaded. So there was the DOM content loaded event. Document ready. It took quite some while. That's on low 3G, by the way. It's not on cable or something. It's just 3G. Now I'm going to show you the updated version when we included critical CSS and asynchronous web font loading. Again, that's the website. I'm going to click on the network tab, then on record, and then you're going to see the build-up of the website with those optimizations. And I click it, pay attention, check, it's here. And as you can see, it's still loading the web font. It takes some time till the web font is activated, like here. About 8 seconds, still on low 3G, but the user was already able to read our website. After 400 milliseconds, we were reducing the time to display from 8 seconds on slow 3G to 400 milliseconds by just doing 2 optimizations. I think that's kind of impressive. And still, I don't know if you've seen it, I was just talking right next to it. After 8 seconds, the DOM content loaded event triggered at the very same time. But the visual representation for the user was a completely different one. But to be honest, I'm not 100% happy with the critical path CSS. While it's good, it has one fundamental flaw. That is, it doesn't include the scrolling behavior of the user. That's a chart made by Mover. They were kind of tracking the scrolling behavior of the user from users on their site. And they found out that after 4 seconds, about 9 to 11% already scrolled down. And if you are on the phone, you're not just scrolling down a little bit, but like that, like next slide, next slide. And it goes on. The more you wait, the more people are scrolling down. And that's critical for critical CSS because everything below the fold is not considered, it's not taken into account. So you also have to know the scrolling behavior of your users to do that. That's how it would look like if we had some master scroller on our website. This is a meetup, a local meetup group I'm doing with Tom Einwaller, who is also here at this conference. And this is the above the fold content. Below the red line, there's the below the fold content. And it looks kind of the same. So if the user scrolls down, he gets something like this on the complete version and on the non-complete version. So we don't want to give our users this. They should have something like that. And what we did to cope with that, we were actually finally engineering our CSS just to feature rules that are really, really important, dropping off all CSS frameworks, dropping off all unnecessary classes that you can have, so that we had a style sheet that was gzipped about, I'd say, 3 kilobyte, which is not that much, which feeds into the first load you can get from the server with your document. And then we included the CSS, the whole CSS for all the web pages, directly into the head, instead of having a resource. That's kind of tricky. You have to know your website really good if that's a way to go with. If your website's too complex, that might not be the way for you to go. But other than that, we can optimize our website really good just by looking at the speed index, especially the critical CSS part, since speed index just takes the first frame into account. Is a technique that kind of cheats on speed index. You can get a lower speed index just by doing that, by just giving speed index what it needs to have a good record. So actually, speed index, really good. Use it, and those techniques are also really, really good. There's one thing, however. So speed index should give you an idea how the user feels when using your website, the user. But we are measuring it with web page tests. So why is everything done by a machine and not by the user himself? Think of the variety of your users. Usually you go to web page test, you enter URL, that's just one point of view from a machine. You can choose some options on web page test, like you have 50 locations you can choose from, with 3 different browsers, and about 5 different types of connection. So if you want to have a broad variety of your users done with webpagetest.org, yeah, that's the thing you can count with. And I didn't even get started on screen sizes. So why thinking about what your user might be and trying to do all the things with webpagetest and not just ask directly your user? Let's do it on the client. Let's say the client should tell you the speed index he had when visiting your website, and then you can try optimize. Yeah, there's one cool library called Rum Speed Index that I want to show you right now. That kind of works like that way. So that's the algorithm. I'm going to point out every little detail right now, so you don't have to remember this. That's done on the client. That's done by our JavaScript directly in the browser. The first thing that we are doing is we are going to calculate the visible rectangle, and then from every resource that we have in there, we are going to calculate the timing when the resource was loaded, from start to finish, when it appeared on our user screen. So I've shown you this window performance timing object, and it turns out that's not just for the window, but you can have that also for all type of resources. With that call, you get an array of timing information for every resource that is on your website. Style sheets, JavaScript, images, web fonts, everything that is referenced and downloaded in the network tab. So for the Ruxit website, it looks like that. That's the Ruxit website. And we have 2 resources on that side. We have the logo up there and some head image down there. And then with the resource timings, we get some information when they have been finished, like here and here. Then we are going to calculate the first paint of our website. It's like, it has been blank for a while, and at one certain point, it's going to start render. We need that because we can calculate the time between the request and the start render using the get first paint time. There are 2 calls, one for IE and Edge. One is window performance timing .ms first paint. It's prefixed, but IE and Edge have actually a property in the window performance timing results. Chrome and Opera have some proprietary stuff. you can use with load times and the first paint time. It tells you it's a timestamp when the browser started rendering. For all the other browsers, we can kind of simulate the first render by assuming the following. You have blocking resources in your head. So let's go over all the resources in your head. Check the blocking resources, scripts that aren't asynchronous, style sheets that have been loaded. And do resource timings on that and check whether or when they finish loading. And the last time from all your blocking resources in the head is the first render time. Then we're going to count in the fonts. So fonts are generally loaded asynchronously. We check all the font resources and the resource timing there again. Also, when was the last time the font has finished loading. And then we're going to calculate the speed index based on that. So we have a response start from the window performance timing. That's when the document arrives. And when the document arrived, we're going to load several resources that are inside the document. During this time, sometime the first paint starts. And at some point, the end of paint starts. Usually, that's either window.onload, when all the sub-resources have been loaded, or you can get it from resource timing, like the latest time, or the time that is the highest, is the one where you're finished rendering. So from response start to first paint, the website was blank. So for every millisecond, we had a total difference to the end result. That's why we add for every millisecond 1 point. And then gradually, you are calculating when did the resource start, when did it end, from the whole pack here, to get some sort of idea of the visual completeness of your website. All right. So after you did that, you can tell your monitoring solution what the speed index is like, and you can track it over time from all your users. You know it then how it was for every one of your users, and if you made changes, how it did affect your users. The whole thing is up on GitHub. RUM speed index, downloaded it. That's from my repository. I didn't do the original. It was from the web page test org guys. I just forked it and experimented with it and did some extras because this RUM speed index just takes the first frame into account, the first viewport load. I want to kind of adapt it that it takes any viewport into account or any state of your website into account where the user has actually been. So you don't have this this break when the user scrolls and no styles are available. Check it out, try it, see how fast is your website, how many milliseconds that you get and that your users get. And if you want any updates on that or enjoyed it, hit me up on Twitter. And I'm working for a company called Dynatrace. And for the Ruxit product line, that's kind of weird because Daniel was here before. He's also working for Dynatrace. But I was working actually for a different company called Ruxit, which was kind of the same company, but different. And now it's again the same company. That's why I'm putting the Dynatrace handle here too. Anyhow, I work there. So if you enjoy performance, if you want to know more, hit us up on Twitter. And I thank you for your attention. I always keep it to half an hour, which is amazing. So we have still 10 minutes time for questions. And if you don't have any questions, well, go outside and look for a drink or just wait for the keynote to get your drinks. Yeah?
I have a question about single-page applications.
Yes.
Should the speed index be measured differently on them? Because the first load is also always the slowest, but other loads are...
Talking about, the question was single-page applications, how the speed index behave. The RUM speed index, the real user speed index, or the speed index from web page test?
Well, it's more like a technical question.
Yeah. The cool thing is that with speed index, the web page test org speed index actually checks the whole progress of a site, the visual progress, in keyframes. That's actual images of how your site looked like. So if you have some sort of preloader that runs, and then you have the website ready, it takes all that into account because it's just interested in the end result when there is no visual change anymore. Web page test org stops when it knows that there's no visual change anymore, which also means that if you have some sort of carousel going on or a video, it still keeps calculating differences. Videos are really, really hard for speed index to get. But yeah, you can argue, is a video good for the user's experience because he has to load a lot of stuff, but yeah. Anyhow, so the web page test or speed index is totally good with that. The run speed index is good with that on the first load, because here you can call run speed index at any time you want. If you want, you can put the user on your site and wait 10 seconds and then calculate it, because it's just interested in the resources that are on your website. So if your single page application loads, let's say Angular is booting up and Angular says, okay, I'm finished, you can call the run speed index function and get the speed index of all your resources on the page. So that's also very robust there. It's not that good when you do a page switch in the single page application, because it's a single page application and run speed index considers pages. If you have some UI switch there, it won't take that into account. But I think you won't need it. Anything else? Very good question, by the way. Okay, if there's nothing else, enjoy your evening. Thank you very much.